afternoon, everyone, and welcome to today's online training, Moving Your GIS to the Cloud. My name is Emily Jarvis, and here at GovLoop, I'm our Senior Online and Events Editor. And thank you to our partners at Amazon Web Services and Rock Technologies for helping us put on this training. So let's dive into it. Government agencies are tasked with modernizing their GIS while at the same time struggling to support outdated hardware and siloed systems. These challenges do not allow agencies to be agile, collaborative, and mobile. So how can organizations transform their GIS capabilities? Well, the good news is that today we found 4 wonderful experts who will share how organizations can stream GIS software directly from the cloud to any end-user device without any software downloads or installs. But before we get to that good stuff, I do have a few housekeeping items to go over. If you're on Twitter, please share what you learned using the hashtag GLTrain. The person who tweets the most using that hashtag will receive a GovLoop t-shirt. On the console, we've got some great resources available for you to download, including a guide to cloud security in government today and this slide deck. It's right there on the right-hand side of your console, so make sure you check those out. We hope you don't have any technical difficulties, but if you do, send us a message to that Ask a Question box, and my colleague Maddie will make sure to get your questions answered. It's in that same portal where you can ask our experts questions. Please take a moment to fill out the feedback survey on your console. We appreciate your feedback as we look for small ways to always improve our online trainings. Finally, we are recording this training and we'll email you a link to the on-demand version tomorrow. So let me introduce you to our wonderful speakers. First up, we have Jason Harris. Jason is the Chief Technology Officer at Rock Technologies. There, he is the Technical Lead and Director for all managed cloud services and hosted infrastructure projects for Rock Technologies, where he's worked for more than 20 years. Jason is recognized as an industry expert in ArcGIS enterprise implementation, system design, and virtualization. Joining Jason, we have Carol Bulzer. She is the Network Administrator at Rogue Valley Sewer Services. Carol has worked for the government her entire career and with Rogue Valley Sewer Services since July of 1991. Carol was a GIS specialist from 2003 to December of 2005 when she became the network administrator. Carol's colleague is David Forbus, who is a GIS technician at Rogue Valley Sewer Services. He's worked for Rogue Valley Sewer Services since March of 2015. Prior to that, he was a GIS specialist for Pueblo Tribal Administration in Albuquerque, New Mexico. And finally, we have Vinath Narshamin, who is the Senior Product Manager at Amazon Web Services. He leads the product management for Amazon AppStream 2.0, where he has more than 7 years of product management experience in building online, retail, and cloud computing services. Obviously, we have a ton of GIS expertise in the room with us, so I am going to stop talking and I'm going to hand things over to Jason Harris. So Jason, the floor is yours.
Hey, thank you very much. So let me just start off and welcome everybody. I'm glad you're here. We're going to talk about some really cool stuff. But first, I'd like to give myself a little street cred. Basically, why would you even want to listen to me? Why do you care what I have to say or Rock Technologies has to say? Well, I'll just give you a brief, quick outline. We've been partners with Esri since 1997, and I have personally been here at Rock since 1998. So, I mean, suffice to say, we've seen the evolution of GIS and the cloud, and as we were, very early adopters of the different cloud technologies available. So basically, that means that we have expertise in both cloud and GIS, and currently we manage, many different organizations, ArcGIS enterprise environments inside of AWS. And of course, logically, that means that we're also advanced technology partners with Amazon Web Services, and that hopefully lets you know that we kind of know our stuff, right? But honestly, and it really comes down to this, that I am and Rock Technologies, we are a bunch of very passionate GIS techie nerds. We love GIS, and we love to show people, what the cloud can do for your GIS. So the big first question is, why would you want to move to the cloud? Why would you want to move your GIS into the cloud itself? So let me just start by covering some of the biggies. Can your organization currently scale, right? So what am I talking about? Well, we all know about a planned scale, right? This is when you want to increase your capacity or maybe add new application servers such as image server or geo event. What do you have to do now? You have to get with IT, make sure you have all these hardware resources. If you don't, you have to order some new ones. Then you have to build out the new machines. And I think we're all probably very familiar, but this is unfortunately a very lengthy process. It takes a lot of time. But then the more important thing is how do you scale for a big unplanned event? We can all see that natural disasters, at least they appear to be occurring with greater frequency. Things like hurricanes and floods and wildfires. Now, consider that your GIS is mission critical. It's providing mission critical information to emergency responders or evacuation routes for the public. And what's going to happen when these big events occur and your traffic spikes, right? Your GIS is not going to do anybody any good when your servers are completely overwhelmed and can't effectively serve out the data. So scaling up to meet those types of demands in the cloud are literally as easy as clicking a button. And there's also tools in place that can let you auto scale, which you don't even have to do anything. It will automatically scale up for you. So point is, we at ROC, we've seen these types of events. They happen all the time. And a cloud-based infrastructure can immediately help you scale to meet those demands. And just as quickly as you need it to scale up, you can scale back down to save money after the event. The next big one, is your GIS resilient? Here's some questions to maybe ask yourself. What is your disaster recovery plan? What happens if power or internet is actually cut to your facility? What happens if your enterprise data store or your enterprise geodatabase becomes corrupted? How quickly could your organization actually recover from that? Suffice to say that adding these types of resiliencies in the cloud is very, very straightforward. Deploying your GIS infrastructure in, let's say, multiple availability zones, which really just means different physical locations, right? You don't want all your eggs in one basket. Anyway, that type of operation is very straightforward and easy to deploy. We can have automatic snapshots, backups that are shipped off to other geographic regions. These are very, very easy to script in a cloud environment. So consider a catastrophic failure of a cloud server, unlike one that's on-premise. Would a hardware failure or an OS corruption, be a big deal? Actually, it really wouldn't be, because then you can, if you've had your automatic failovers in a high availability environment, or you could just spin up your server image on a new host. Now consider that type of scenario with an on-premise server. What happens if your RAID array goes bad? What do you have to do? You have to call Dell, wait for them to ship the drives, rebuild. We all know that that's going to take a whole lot of time. Lastly, I'm going to touch on security in the cloud, which I really do think is perhaps the topic that gets maligned the most. Systems in the cloud, I would argue, are more secure than those found on-premise. AWS has deployed extensive monitoring tool sets for intrusion detection and remediation. These tools are straightforward in their setup and enable you to use real-time monitoring in the cloud. So now consider trying to do the same on-premise. Think about the complicated, time-consuming security suites and then security hardware appliances that need to be installed and maintained on-premise. And this is not even talking about how easy it would be if you're on-premise to walk down to the actual physical server and somebody slips a hard drive in, or a thumb drive into the USB port. That's not so likely to happen at the cloud. But actually, really, with any system, whether this is on cloud or on-premise, you got to have the expertise and the tools for the job. You should not take security lightly in either case, but I will say that the tools that are out of the box, readily available in the cloud are fantastic. So again, we're going to continue with moving to the cloud. Basically, right now, the cloud is fully mature. You can effectively move your entire enterprise GIS environment to the cloud. ArcGIS server, portal, databases, all your public-facing applications with all the integrated identity providers such as your on-premise Active Directory, and this all works great. But we continue to see organizations deploy these standalone, disconnected environments for like a specific purpose, like maybe to provide public access or specifically to power a specific application. If you think about that, that's missing the most important part of a fully deployed enterprise GIS, and that's your users, your editors, your analysts. So some common questions that we'll always hear when getting ready to deploy a cloud system or just answering questions. The big ones are, so how do our ArcMap and ArcGIS Pro users interact with this cloud environment? How do we get our data back and forth between the cloud? How can we update our data? Do we have to use geodatabase replication or weekly data dumps from our on-premise editors? So when I actually hear these questions, what does that mean to me? Well, it means that people still think that they have to maintain these two separate systems, one in the cloud and one on-premise. And quite frankly, we see this all the time. The cloud is being used for a specific purpose, like a hosting server will be up in the cloud to serve out maps publicly, and then on-premise they'll use for their everyday analysis and editing. Those two systems are separated. And at the end of the week, people will have to manually push up their data to the cloud environment or rely on geodatabase replication, which we may all remember that can be a little bit of a pain sometimes. These types of processes are both inefficient and expensive in terms of both hardware and software licensing costs. That all really adds up to a lot of lost productivity, and it's going to cost you quite a bit of money. A second scenario that we will see pretty often when setting up these cloud environments, or people that have attempted to set up a cloud environment, is they'll deploy an enterprise geodatabase in the cloud, and then users will try to access and edit that data locally on-premise from their PC. I can tell you that you've probably experienced this yourself, but spatial data is very thick and it's very heavy, and it's tough to drag that over the internet. So the latency issues there are going to be pretty awful. So in that scenario, it's just not going to perform adequately. So the big question is, how do you do it? How do you bring all of your users together? Well, the solution is to bring everything and everyone to the cloud. There are lots of different VDI solutions around, but Amazon provides a turnkey, out-of-the-box, and easy-to-deploy application virtualization technologies. Okay, what does all that mean? That was a mouthful. That means that you can run ArcGIS Desktop, ArcGIS Pro, and all of your other everyday applications that you use in your workflows directly in the cloud, and then simply stream the pixels to your local desktop. And that local desktop can be a dumb terminal, a Chromebook, it could be a tablet, it could be a Mac, doesn't matter. And it runs fast, and in most cases it's going to run faster than your on-premise system. The idea here is that you're taking advantage of the inexpensive compute resources like CPUs and RAM and GPUs, the graphics cards that are now needed for applications like ArcGIS Pro. Those resources, those items are run in the cloud where everything is cheap. The big takeaway here is that you can run these applications from literally anywhere that you have an internet connection. You don't need to have ArcGIS Desktop or Pro installed locally. For example, out in the field or if you're at home, it doesn't matter. You still have access to all of your applications and all your cloud-based data. The best part really here is you're only going to have to pay for what you use. As people are starting to move into the ArcGIS Pro environment, we probably know that that's a pretty power-hungry application, and the specs to run ArcGIS Pro, and especially doing some of the more 3D intense modeling, a workstation for something like that can get quite expensive. So If you're only going to pay for what you use in the cloud, this becomes a very cost-effective way to get access to some extremely high-end hardware. And we're going to talk a little bit more about AppStream in just a little bit, so stay tuned. All right, I had to take a sip of water there. Moving to the cloud is cost-effective. GIS on the cloud is very cost-effective, and it is very easy to demonstrate a very competitive ROI. Let me give you a little examples here. Doing some just really brief, quick calculations for a new on-premise deployment. Let's quickly run the numbers. Let's take, for example, two minimally spec'd out Dell rack servers, some R730s. We'll use one for the VMware host, and we'll use a second for redundancy in case of that primary host failure. Let's add in some 6 laptops or desktop workstations for your everyday users of ArcGIS Desktop. And now that people, again, like I mentioned, are starting to utilize ArcGIS Pro in their daily workflows, let's add in 2 GPU-enabled workstations that will be capable of running ArcGIS Pro. Of course, as I mentioned, you probably know by now, ArcGIS Pro means a lot more CPU, a lot more RAM, and most importantly, it's going to need a dedicated GPU that's going to make all of those 3D visualizations possible. Lastly, we'll add in some of the licensing that we'll need for the OS and the virtualization hosts. Now, we came out with a pretty conservative low-end estimate, and we're already looking at $50,000 for a base ArcGIS enterprise deployment. So if you're like most folks, you're probably also on a 3-year hardware refresh cycle. So that means when you're budgeting out now for your new system, you had better plan for the future expansion that you need right now. So you need to be thinking about what your requirements are going to be for your GIS in year 3. Is the current hardware going to be enough? Honestly, probably not. So you're probably going to end up spending far more for that baseline configuration, over provisioning yourself for what you think might happen in year 3. And that has the effect of effectively overpaying and over provisioning your hardware in years 1 and 2. Now let's take a quick look at the cloud column where I have added a roughly equivalent system. Short answer, it's going to cost you about $11,500 per year. But the very important thing to realize here is the scalability of such a system. As your needs change, whether it be in 3 months or 3 years, you have the immediate ability to scale that system, like adding more compute capacity to an ArcGIS server or bringing on additional ArcGIS applications like GeoEvent or Image Server. This is all possible without waiting on that 3-year hardware cycle and crossing your fingers that IT will give you another box. So how do we make that happen? How do we prepare for this move to the cloud? The big one is we've got to prepare. How do we do that? And it all starts with a good assessment. And I really can't stress this enough. You have to understand your organization's needs. So we got to start asking ourselves these questions. What do we need to accomplish? Are we currently running a system on-premise? Does it currently meet our needs? Does this system have any big pain points or performance bottlenecks? Are there things you could be doing better or more efficiently? What about future growth, like adding in new features to your ArcGIS enterprise system? Is it time to switch to Pro or maybe take advantage of GeoEvent? Will we be integrating with a single sign-on system or a SAML provider? These are just a couple of the things that you should be talking about and asking yourself these questions. Next, and this is a big one, it's document. We really, really strongly suggest that you diagram out your current system and leave no detail undocumented. Things like map services, all your portal users, your permissions, your scheduled jobs, your scripts, your privileges, your view and edit privileges, all your web applications. The key here is to be exhaustive. And when this is done well, the migration go live date will be smooth. architect. Now, this is obviously a very key step. We will often get calls from folks that maybe gave this a shot but didn't quite get this step right. While the principles of an on-premise and cloud system are similar, both systems are using servers and workstations, they're also very different when it comes to actually architecting and deploying. It is extremely important to have someone available to you that is familiar with the best practices of a cloud deployment. Really, the key here is don't be afraid to get help from an expert. Some of the common mistakes that we'll see, this is just to keep in the back of your head. Many folks will either over-provision or under-provision their systems, and that leads to either a terrible performance or you're going to blow your budget real quick. Another issue is lax security. Many people will roll out their systems with security as an afterthought. And then a big one is make sure you've got a proper disaster recovery plan. I won't really go too deep into this, but just take the pre-built tools that are there to take advantage of the built-in cloud redundancies and the different availability zones. In short, don't put all your eggs in one basket. And lastly, the migration plan. Think about what's best for your organization. Do you need to essentially do a lift and shift of your current system as it is now right directly to the cloud, or should you design a new system? There's several available tools that will let you do a real-time replication from your on-premise servers directly to the cloud. And if you have a very large system, this could be a great option. On the other hand, we see lots of clients taking this migration time to think about the future and how they want to modernize their GIS system to maybe take advantage of the newer technologies and tools that are available. In this case, you can deploy a cloud-based system that runs in conjunction with your current on-premise system, and then migrate your tools and data. Fully tested and verified, we'd cut over to the new system and retire the old. That is it for the brief cloud overview, why we'd want to move to the cloud. One thing I do want to mention is that you make sure to hang on for the entire presentation. I've got something really, really, really exciting to announce at the end. So hopefully you'll hang in, you'll see the slide at the end, and this is kind of exciting stuff. For now, I'm going to hand it over to Carol and David at Rogue Valley so they can show you a real live example.
All right, thank you so much, Jason. I am taking it. All right, so this is Esri in the Cloud, which we have now. Again, this is Carol Balzer, Network Administrator from Rogue Valley Sewer Services, which is a government special district. So we were voted in by the citizens of Jackson County back in 1966. Located about 33 miles north of the California border along I-5, which is the major freeway down the west coast. We have about 22,000 business and commercial customers and employed 36 people so far, over 6 departments, and about half of them are field workers. So as you can figure, we had some challenges ahead of us. The inspections that we are covering currently with our new cloud system, I'm kind of jumping back and forth between cloud and not cloud at this point. PV and flushing our gravity lines. We inspect 29 pump stations. And we have a stormwater MS4 that we have to do all of the required EPA inspections for. Challenges pre-cloud. Some of these might look familiar to you. Our data was saved in various locations, including on paper form in file drawers that we never accessed. Maps reviewed in the office on our GIS desktop in the field with ARC Reader. And we had to print out some maps for our PV and flushing crews so they could track them manually. Our crew laptops, field crew laptops, had to be updated whenever we made changes, and that meant bringing laptops back into the office and running a script that would update all the information. Our inspection tracking was redundant, where our TV and flushing crews would fill out a form, print it out, hand it to their clerk, who hand-entered all of the information in there, exposing us to possibly some errors. No doubt we had some. And our map changes were requested on paper, and at times I saw stacks probably 2 reams high of paper at our inspector's desk. Not fun for them, and many times there were duplications in the requests. And this is pretty much what our system looked like before the cloud. Nothing was connected. And now, in the cloud, our inspection and map change request applications are map-based. We use Esri Collector and Survey 123 to collect the data in the cloud. The maps are viewed electronically, anywhere, anytime, by our field crews and in-office folks. All changes to any of our data is reflected pretty much immediately after it is updated. And Rock Technologies has been a godsend. We are given the flexibility through Rock Technologies to create new apps, have our old apps changed whenever we want to, and they are extremely responsive to our system. We do access our GIS system through an open internet access. We don't use a VPN. And we are using Enterprise and GeoEvent on the AWS. And this is what we look like now. We are pretty much GIS-centric. We're working on, we have many more applications that we want to do, and are looking forward to getting more and more of our system into our cloud GIS data. And you might ask, how do you get your information from the cloud? Our reporting tools include Crystal reports using ODBC. Have a handful of dashboards, Esri dashboards, that have been quite helpful to our managers and crew leads. And we just started using Esri Insights, which is exciting. And now I'll be handing it off to David, who will be talking about the AWS.
Thanks, Carol. I'm David Forbes. I'm the GIS technician here at Rogue Valley Sewer. I'll go through how we're kind of give you some examples of how we're using it here. Here's what our GIS structure sort of looks like right now. We have the center portion with our geodatabase on a SQL server feeding into Portal, and that portion is managed by Rock Tech. And our staff will access most of the data through the portal. So we have various web apps and viewers set up, as well as ArcGIS Collector. That's the primary app that they're using to write to Portal. So the general staff will use that, as well as the public-facing maps. Everything goes through Portal. And GIS staff would access the database directly using AWS and use ArcMap for that. So we're going to do any kind of big database updates or scripting, adding and removing features, any kind of table changes, we do it straight through the Amazon workspace. We're currently using the Power package on Amazon. Originally, we were using the Power package is 16 gigabyte memory for CPUs. We were originally using the package below that. It was only 8 gigabytes, so it wasn't quite meeting our needs. And Jason mentioned the scalability that you can implement through AWS. And So, we said we wanted to upgrade, and it was nearly instant. They just changed us to a new package, and it was available to us right away. So that was incredibly useful for us. Also mentioned that ArcGIS Pro needs a GPU to operate correctly. So you would need to get the graphics package as Pro, which we currently aren't using. We're using. Here's what it looks like when I log into the workspace. It's essentially a remote desktop. I have full access to install programs as needed. I can do work here in the workspace, and especially if it's like a scripting that I'm trying to watch and make sure that it's running correctly, I can set that running, minimize this workspace, go back to my on-site desktop, and continue to do other work. So it's not affecting my on-site desktop at all. And here's what it looks like, just your standard ArcMap on the workspace, and you can see I'm connected directly to the SDE database connection. So this particular one is our map changes map. So when I get map change requests, I'll actually load in the record maps that the inspectors have corrected already, and then get the GIS to match what the field crews have found out. And I just did a couple of speed tests on our workspace, and these are the numbers I was getting. You can see they're fairly fast. If you consider your own home high-speed internet is anywhere between 50 and 100 megabits, I'm getting 500 to 700. It's been incredible. They're very low latency as well. You see the ping is only 8 milliseconds, so that's been useful as well. I'm going to turn it over to Vinod now.
Thank you. Hi, everyone. My name is Vinod. I'm a product manager at AppStream, which is an application streaming service from AWS. So what is AppStream? And Jason covered a lot of ground for me, so I'm going to move fast on these slides. So this is the traditional GIS workflow that you guys are all very familiar with, that you do on a daily, day-to-day basis on your traditional graphics workstations. What are all the challenges with that? One is modern IT organizations are facing with new models with which employees are organizing themselves. You're having contractors coming in and working on short-term projects. You have a lot of employees wanting to work from home, and organizations are going global, acquiring companies, which means there are more and more employees and users who remote and distributed. The business models are evolving. You want to bring your own IT, where employees are empowered to buy whatever devices they want, be it a MacBook or a Chromebook or a Surface Pro, and then still be able to productively use all the applications they need on a daily, day-to-day basis. Security challenges have increased. Modern day security vulnerabilities are much more powerful and much more dangerous than what it used to be. And you don't want your applications and data that are installed on end-user devices to be exposed to these vulnerabilities. GPU workstations are expensive, as folks before stated. For ArcGIS Pro, for folks who are editing and using ArcGIS Pro like software, you need powerful graphics workstation or on-prem hardware. And in many cases, you have to plan for your entire user base, even though not all of them are using it concurrently. This means you have to plan, invest, and procure the hardware, and you have to maintain that planning and capacity cycle well ahead in time before you could scale and meet the needs of your user base. Many of the customers have migrated their data to AWS. There's a number of storage services available, and the cost of storing data in AWS is really cheap. It gives a lot of flexibility and security for customers. However, the client applications are still tied to the on-premises. There's a lot of data transport network latencies, moving massive amounts of data that your applications need from AWS to the network, and many cases where if users are working from their home, they don't have internet connection that supports these kind of data transport necessities. And time to market is shrinking. There are lots, internet has created a level playing field where even a startup with a few employees can reach customers at scale globally. This means existing RTI organizations have to become more nimble, more dynamic and flexible to react to the market needs. This is what AppStream enables us. AppStream, along with other AWS services, enables you to operate faster. It enables your employees to iterate on GIS workloads faster on cloud using any device they want. You're able to put your apps and data together, and by that, you're eliminating all the network latencies associated with it, giving your users a very fluid, interactive experience, even when they're accessing massive amounts of data. It gives you the agility to respond to your employee needs. You don't have to tie yourself to device constraints, upfront investments, capacity planning, and things like that. So what is AppStream? AppStream is a fully managed application streaming service from AWS. We provide you the infrastructure to run your applications on cloud. Your apps get all the compute, memory, and GPU, and the service streams the application as a web application to end-user devices, enabling your users to instantly access the desktop applications they need securely using any device they want. All your apps and data are secured within the AWS cloud, and AWS employs modern security standards to ensure your data and apps remain secure. And AppStream only sends encrypted pixels to end-user devices, ensuring that there is no data or application footprint on end-user devices. What are the benefits? You can write GIS apps in a browser. It could be all you need is a modern HTML5 browser on your device. You're able to instantly access your apps. As IT administrators, you can centralize the application management. You patch your applications once, and all your users instantly receive the updates, instead of you worrying about having to patch or update the application in every one of the devices in which your apps are installed. You can bring your own data. AppStream seamlessly integrates with your existing IT environment, so you can move your client apps, but you don't have to move all your licensing servers, database servers. We strongly recommend moving them as well to realize the full benefit of AWS, but you don't have to. By extending your data center to AWS, you can make your applications running on AWS to seamlessly talk to your existing servers deployed on premises. You don't have any workstations to manage. You simply start an environment with a few instances in a few minutes, and then you can scale that instantly to however instances you want, scale it down to however instance you want. If you're doing a project as an experimentation or a research, you can simply launch however instances you want on cloud and then shut down without worrying about the capacity planning for it. It's high fidelity visualization at global scale. AWS has geographical data centers deployed throughout the world, and by that, you're able to provide your end users, no matter wherever they are located geographically, the best fluid experience on a network device. So this is a brief example of how your users would access. They can access it over internet. They can access it over your corporate VPN, and the application is running on AppStream. The application running on AppStream can talk to your GIS data deployed on AWS. I'll skip the demo part. I'll leave the surprise that Jason has for you guys. Simple user experience. We offer a very simple web interface. The user simply log into a web portal and start using their apps right away. Your users can use multiple applications at the same time. This means that all the applications are running on a dedicated streaming instance on cloud, and you're able to provide users not just with ArcGIS Pro, but if there are other applications they need, they can use them together within a single session without having to open multiple browser tabs or things like that. We provide multiple identity models that allows you to seamlessly authorize and authenticate your users. We provide single sign-on federation through SAML. You can bring your own identity and integrate it with AppStream. We also provide built-in identity within AppStream to create user accounts and then provide them access to your AppStream applications. We provide various storage options that allow users to bring their own storage or use the storage options provided by AppStream. We provide various instance type. An instance type is a particular hardware configuration on AWS, and every instance type comes with multiple instance sizes. Every instance size under a particular instance family has a certain amount of CPU cores, certain amount of memory, and certain amount of GPU. So for 2D workloads, the memory optimized instance works perfectly great. and the price of that starts at 25 cents an hour of an instance running on cloud. I'll briefly detail how the pricing works for AppStream shortly. And then for more powerful needs, you have the graphics design instances, which allows you to choose an instance with GPU at just 50 cents an hour. How AppStream is priced? AppStream provides every user a dedicated virtual machine on cloud. It does not allow shared hosting of users because every user wants a consistent performance of using their applications. This means, especially for graphics applications. We do not put multiple users on the same host, thereby creating noisy neighbor problems. You pay per hour for the running instances. Every instance, since it's dedicated to user, if you want to have 100 concurrent users, you need 100 instances to support that need. And you pay for every hour of the running instance. So in this case, for every hour of an instance that is running, you pay for it. So for 100 instances, that will be the total cost. There is a monthly fee for every user who connects and starts a streaming session. This is a Microsoft RDS SAL fee, which is the fee charged by Microsoft for every user connecting to a Windows Server instance on cloud. You can pay for that license through us, and it's a pass-through fee for us, or you can bring your own existing licenses. Many organizations have procured the RDS CAL licenses directly from Microsoft or from a Microsoft reseller for their own on-prem needs. You can bring it to AWS. And if you're an educational institution, you can qualify for EDU pricing. This charge is $4.19 for every user per month. However, for EDU customers who are using for educational needs, so say for students or for research staff, this price reduces to 44 cents per user per month. The instances doesn't have to be fixed in capacity. And you start with a handful of instances, say 10 instances, and then AppStream will ensure that your service scales up and scales down by launching instances on demand to match your users. This way, you pay only for what you're using at a given point in time. You do not have to worry about procuring a hardware base for your entire user base. AppStream offers two fleet models. One is what we call always-on instances. In this, the instances are created and kept running. So the standby instances that are ready to accept a connection from a user are running. When a user starts a streaming connection, they're able to instantly get access to their application without any wait time. However, you pay for the running instances and you control the number of instances running at any given time. Sometimes customers do not want to have instances, standby instances running. So what they basically want is they want to put them in hibernate state. So what we offer another model is what we call on-demand model. In this, the standby instances that are ready to accept connection to support your users are put in stop state. And there's a wait time of about 40 to 60 seconds to prepare an instance from a stopped pool and make it ready for the users. This is much more cost effective than the always-on model because when there are no users using the environment, you're not incurring any charges, any running charges. As I said, we provide every user with dedicated VM. We do not put multiple users on the same VM and degrade the performance that every user gets. AppStream is available in more than 8 geographical regions right now. We are in these geographical regions are a cluster of data centers of AWS. So we are as you can see, the spread is pretty good, providing any user globally distributed to give a very fluid application streaming experience. The streaming protocol that we use to stream the pixels of applications from cloud is very adaptive. It can automatically adjust to network conditions. It operates very effectively on low bandwidth networks as well. It automatically adjusts the image quality based on the network bandwidth that is available to it. The streaming itself works over HTTPS. This means you do not have to open any ports. You do not have to go through complex network configurations in your network firewall to make AppStream work. It just opens just like any other HTTPS website. The pixel itself is encrypted end-to-end. So you are using AES 256 encryption, the modern encryption standards. And we provide different instance types for you to choose depending upon what applications you want to run. We offer various identity models. The app streaming instances, your app stream environment can be standalone, or it can be joined to an Active Directory domain of yours. If you want to apply your group policies, your compliance, your security aspects of it to the streaming instances on AWS Cloud as well. We provide, as I explained, we provide single sign-on federation. So if you're using identity services like Okta, Ping, Active Directory Federation services, Shibboleth, you can seamlessly integrate AppStream and then let your users federate to an AppStream stack without having to create a new user account. They just could use their corporate credentials to sign in and access their applications. For small and medium scale customers who do not own their own identity model, we also provide built-in identity with an AppStream. If you're a workshop with 5 to 10 users, within AppStream itself, you can create user accounts using email addresses. Your users will get a web portal to which they can log in and access their ArcGIS Pro applications. Storage, AppStream instances are non-persistent in nature. That means when the user starts a session, we provide them a virtual machine on demand. But when the user ends the session, that instance gets terminated. What this means is there is no persistency of the instances. That means you only pay for what the users are using the instances for, giving you a much more cost-effective option of maintaining an infrastructure to run ArcGIS Pro. However, we provide data persistence. We provide application settings persistence. So with a simple click, you can enable a virtual drive for every one of your users. Your user will get a D drive to which they can, and this is called home folder, to which they can store their data, and it will be seamlessly made available in the next future sessions they launch. We back the data automatically and make it available in new sessions the user launch. If you are an existing Microsoft Office 365 customer or a Google Drive or G Suite customer, then we provide native connectors to Google Drive and OneDrive for Business. This means that you can enable your users to link their OneDrive or Google Drive accounts and use those storage within the app streaming environments as well. AppStream instances are launched within your VPC on AWS. This means you can bring your own network file shares and then make them available to your users as well. We provide tools that allow you to upload files and download files from the remote session, thereby allowing users to upload a file to the remote session from their local computer, download it back, or print. I briefly explained this. So the service is fully managed. There's no hardware or software for you to manage. You simply bring your applications, install it within AppStream, and then we create all the virtual machines on demand. We manage the user sessions. We terminate them. We provide storage. We back the user's Windows profile so that whatever changes they make to the applications and the registry keys are automatically backed up and applied back. So here are some of the customer references. We talked about Rock Technologies. Ivari GIS Consulting is another GIS consulting firm that's using AppStream. And Esri themselves are using AppStream for their internal needs. There is a blog post that was recently published by Esri themselves where they're talking about how ArcGIS Pro can be streamed from cloud using AppStream 2.0. We have published a dedicated deployment guide that allows any new customers who are even new to AWS to start with an AWS account and deploy ArcGIS Pro very easily to their end users. And this guide goes through step by step, assuming no preliminary knowledge of any of the AWS technologies. And there are lots of valuable information available on our website. I'll pause there. The rest of the slides are appendix, but it just talks about what's the setup. And these setup details are very clearly explained in the deployment guide. So as you walk through the deployment guide, you can easily understand how AppStream is set up, how it provides your users access, and what you need to do to provide a modern GIS environment from cloud to your users and let your users instantly access their apps on cloud. Back to Jason.
Thanks, Vinath. That was a lot of really good technical information. So, we started off the webinar with, why we want to move to the cloud and moving to the cloud and how people have the two different systems set up. And, the big missing piece has always been, how do I get my everyday users, my everyday editors, my applications, how do I use them, right? And then we went off and we saw an example from Carol and David about how they're actually, fully in the cloud. It's totally changed their workflow, and they're, much more productive, and everything is electronic, no more pushing data back and forth. And then Vinath kind of showed off some, the technical aspects of AppStream and, what this is. The big takeaway is that, AppStream runs directly out of a browser, and you can then use ArcGIS Pro, ArcGIS Desktop directly in a browser. There's also a thin client that you can use as well, but it works natively right out of the browser. So that was it. So this is where I'm kind of excited to share this news. So normally what I would do right now is I would launch AppStream and try to demo it and show you just how easy it is to use AppStream and launch and use ArcGIS Pro in the browser and all that stuff. That's what I would normally do. But I am very excited to share this news that we have partnered with Amazon, and we're going to provide everyone that is attending the webinar with a pretty, unique opportunity. So soon after the webinar, you will be getting an email. So after this webinar, meaning either later this afternoon or tomorrow morning perhaps, you're going to be getting a follow-up email from us. And in that email, you are going to have a link to this sign-up page that we've shown here. After you sign up and register, you're going to get a confirmation email, and that go back and confirm your email. And what that's going to do, now that you've been confirmed, you are going to be brought to your very own AppStream instance. So this basically means everybody is going to get to test out for an hour ArcGIS Pro running on AppStream. So yeah, I can hear the applause from here. One thing that is extremely important, so you'll get to this page and you'll launch ArcGIS Pro. Now, remember what Vinath was talking about, the differences between an on-demand instance and an always-on instance. It's important to remember that what we're using here is an on-demand instance. So when you click that icon to launch ArcGIS Pro, it's going to take a couple of moments for that instance to spin up, and then eventually it's going to go ahead and launch ArcGIS Pro, which will get you to this screen that everybody is probably familiar with. This is very, very important. You're going to need your own existing ArcGIS Pro license in order to use this demo. We unfortunately can't hand out Esri licenses like that. But so before you do this, make sure you've got a ArcGIS Pro username and password so you can log in as you normally would with ArcGIS Pro. So when you log in, it's automatically going to open up a default project, and you may, just by this screenshot here, you may recognize this. This is a demonstration project that Esri often uses to showcase some of the ArcGIS Pro advanced rendering capabilities. It's one that's notoriously tough on the CPU and the GPU. So if you've ever tried this project locally on your PC, you know what I mean. It's a bit of a dog. It's very, very CPU and GPU intensive. But what we wanted to show, the point of this whole thing, is we want to show you that ArcGIS Pro on AppStream will just literally slice through this project like butter. You can also try some more traditional kind of county data. We've got a second project called Brevard that just has some more typical county level data, things like that. You can also, with this AppStream ArcGIS Pro instance, you can connect to your existing ArcGIS Enterprise portal or your ArcGIS Online account to utilize any data or layers that you may have hosted there. This is that Brevard project that's got some parcels and whatnot you can check out. So, want to make sure to remind everybody to watch your email. It'll be coming either later this afternoon or tomorrow morning. Again, you guys are going to get your own logins. You can independently judge for yourself. You can test it from the comfort of your home or your office or wherever. You're going to get to test out AppStream all by yourself. So be on the lookout for the email coming from demo@rocktech.net. And with that, that's it. I'll hand it back over to the GovLoop folks.
Wonderful. Thanks so much, Jason, and thanks to all of our presenters. Now, we don't have much time left, but we do have a few moments to get a few questions into our Q&A portal. And Carol, I'm going to start with you. You know, you had a unique experience, you know, being in GIS and having this, you know, ability to kind of utilize some of these new technologies to make a difference. How did you bring this to your leadership team? How did you get their support if you're one of the agencies listening who's looking to follow your lead?
Well, we were extremely fortunate, and still are, to have a manager whose vision it was to become a GIS-centric organization. So unfortunately for all of you out there who are expecting wonderful pointers, I don't have any. Get a different manager? I don't know. Our current manager is extremely supportive with GIS, any technology, anything to increase efficiency. And this is done that, but good luck to all of you.
Anything to increase efficiency. I think that is great advice. Jason, you're out there, you're talking to a bunch of government agencies. How do you have that first conversation? How do you get the ball rolling with government clients looking to use GIS in the cloud to build some efficiencies and to really track systems more effectively?
Well, it really comes down to what I was saying before. You know, everybody has really embraced, you know, a cloud-first mentality now. Mm-hmm. Everyone is or is thinking about moving their systems to the cloud or has moved their system to the cloud, but there's always been that huge disconnect for the folks that are still sitting on premise using ArcMap or ArcPro. And how do they connect to their resources that are sitting in the cloud? And they've either separated the two. They've got two systems running in parallel, one on premise and one in the cloud, which is terribly inefficient and, you know, very costly. So with these tools that we talked about, and you guys are going to get to demo, you'll get to see that, you know, you really can, you know, use your applications from anywhere, and they're running natively in the cloud. So you're going to, you know, be able to do your everyday work and your editing, and all of that is going to be, you know, live in the cloud, and it's awesome. So once you talk about that, once you can show people that, you know, this is a real thing, you can really do this, the buy-in is pretty quick. You show the return on investment, you show that you can be more efficient. Again, yeah, the government and the private companies, the buy-in is pretty quick.
Awesome. Unfortunately, though, that is all the time we have today. Thank you to our 4 wonderful speakers. I do have a few quick reminders before we sign off. We will email you a link to the on-demand version of this training, so make sure you check your inboxes tomorrow. Also, be sure to download the additional resources in today's slide deck. It's right there on the right-hand side of your console. Please also take 2 minutes to fill out that feedback survey. Our goal with these trainings is to help you do your job better, and we really appreciate and value the work that you do every day. So thanks for taking the time out of your busy schedules to join us this afternoon. On behalf of GovLoop, Amazon Web Services, and Rock Technologies, I hope you enjoyed our online training. Enjoy the rest of your afternoon, and we'll see you at the next GovLoop training.